in many ways as disgusting and objectionable and scary, right? As someone sitting in the chair of the president of the United States in total anarchy mode, trying to disrupt the will of Americans in a purely democratic society. There is reason to rejoice, and I don't want to be distracted by clearly a really relevant moment of American history, which is what we're in the middle of today, because I want us actually to try to focus on the incredible future that Georgia brought us last night. We have in this nation suffered for the last 4 years with a president who literally rolled back most of the advances made for environmental protection. I mean, that's just the fact. And unilaterally pulled us from the Paris Agreement and doubled down on fossil fuels. These are the things that fuel our demise, especially here in South Florida. And although there is chaos in the Capitol tonight, there is hope across America that a climate agenda will finally find itself into our policymaking. And that's all that at this moment we should be focusing on, that we have a House, a Senate, and a president who all understand the predicament that we are in, and that policy will invest in and regulate and double down on trying to create a better climate future. That is incredibly wonderful to me, because now we can begin to make change. And in many ways, we as thought leaders, as activists, as thinkers, as parents, as homeowners, have a bigger role today than we did yesterday. Because yesterday, it was about trying to move a boulder up a hill of resistance, right? It was about trying to get constituents to get a body of government to not block every single piece of legislation. Today, at the head of metropolitan government, of our regional government, we have the most proactive, progressive, climate thinking, forward thinking mayor who will push an agenda that can be supported by a federal government that now has both branches working in function, not dysfunction, to advance an agenda that will support what we as a group of citizens think is important for them to innovate and to think about as we address the crisis of our time. So I know there's chaos. I've been back and forth. In fact, I'm launching another art project just about this moment. But today, in this room, in this sphere of ours, I want us to understand that we have more value today than we did yesterday, because now it's no longer about trying to persuade the unpersuadable. It's about giving ideas and creating platforms and opportunities. And there's no one better to lead us in this conversation than our chair, because that's literally what his job is. That is literally what he does at the University of Miami as he oversees the Sustain Lab and looks for solutions for adaptation, solutions that now can meet even a more open ear in governance as we move our way forward. I'm not going to introduce him. There was a beautiful bio in the letter we sent. He is our chair. He's been our chair since day one, since Daniela Levine, our current mayor, administered the oath of office and made him chair. He oversees ocean science at Erasmus. He's an ocean physicist, and he oversees a laboratory that simulates hurricanes, both through a wave paddle and through turbines, the wind and the waves, to see how we can build a more resilient and adaptable community. He's been with us every single step of the way. He doesn't need an introduction, and he's going to talk to us today about basically looking forward and looking toward the future. So without more to say, Brian, hashtag new day, hashtag new era for this Underwater HOA. Okay. Well,
yeah, thank you. Thank you for the introduction. That wasn't an introduction, Xavier. I appreciate that. Yeah, I guess last night at around 3 when I woke up and checked my phone and saw the results, and I realized that what it looked a little bit I was still fairly confident when I fell asleep, but I was like, okay, I think this is going to turn. But to see that it had, I didn't sleep for the rest of the evening pretty much, because I kept thinking about all the opportunities this could bring, in climate, as Xavier mentioned, and in gun legislation, and just the number of things that you can imagine that people I think have been wanting, but the structure of our Senate had, the Senate had been blocking essentially. So, and I'm very hopeful, because as I see Esber's on the call here, and I think he'll second me on this, is that there's already a tremendous amount of governmental attention, even at the federal and state levels, being paid to climate change by the what we now know as the deep state folks in these agencies, and they've been plugging along. It would have been, I think, catastrophic if they'd had to hold on for another 4 years, but their ability to, just because of the cycle of the government, they operate on these those kind of timescales. They're planning ahead that far when they're looking at their projects and things. So, there's a lot of stuff happening right now that is really encouraging in terms of funding research. That's very exciting. I'm working, and I think that there's removing the potential for just that negative pressure from the political ends of these agencies is going to really lead to a good period for science and communities. And one of the things so I'm working on a proposal right now that is doing essentially trying to provide tools for communities to manage coastal resilience and look at adaptation solutions that incorporate nature-based features or sea level rise and storm surges. I mean, this is the federal call that is out, and this is under the Trump. So I think we can thank all the people that plugged along and stuck with this stuff over the last 4 years, that stayed in these agencies and did that work. And this is across them. I mean, I was talking to an Office of Naval Research program manager today who's celebrating the very same thing, and he's not alone in these agencies. So I think that there's a potential for us to make real progress quickly, because I think that as deleterious they were to the advancement of our communities and science, the political pointies where I think that they were not particularly effective in they did what they could, but their ability to permanently impede stuff was not too great. I'm hopeful anyway. So I was very hopeful last night, and of course today was sickening and is sickening. But
before you start, I want to let you know regarding your proposal about local municipalities. One of our members, she was there when you were inaugurated, and in a handful of our meetings. Leanne Tellum has recently been elected as vice mayor of Palmetto Bay. She's my neighbor. She's our vice mayor, and she clearly believes in what we're doing, and I actually supported her during her campaign because she was one of our members and took notes and all that. So here's another one of our own members where, she had more voice a few weeks ago than she did a day before she got elected, but today she also has more voice as my representative, as my elected official, to do something locally at the municipal homeowner level. And we have Victor and other Palmetto Bay residents here too that we're excited to have you here, Leanne. Thanks a lot for joining us.
Yeah, and exactly. And our local level people have been engaged right through this and carrying us forward, which is great.
Okay.
So I thought that today, to be honest, it's part of, January rolled around and, who's going to speak? And I said, well, okay, I'll step on doing it. So what would I like to speak about? So I thought that I would just I guess it came out of a couple of conversations I had with relatives that I was speaking with over the holidays. Didn't see a lot of people, but the ones I did. And one of my about, and they're asking me, what is a lot of interest in like drones and different things like that. What's coming in ocean sciences? How are you doing all this stuff? So, maybe more people would be interested in talking about that or hearing about that. So I have a short presentation about that, and but please, engage with me, ask questions as we go, because it's not like a very structured presentation that I have. So if you can let me share.
Adam,
Adam?
Can you give him authority? Or do I have to do that?
I think he probably did.
Great. Thanks. And I'm going to go on mute.
Okay, can you see my screen now? All of you?
Yeah.
Okay, so I've been in the field of ocean sciences since graduates, well, since I was, obviously in the university, which is about 30 years now. And I've seen quite a bit of changes happen. And so I'm going to kind of mix what's happening, where I see things going in terms of environmental and ocean science. And there's really kind of three big changes that I've seen. The technology, and I'll talk a lot about that because I'm a physicist, I'm an engineer, this is kind of where my expertise is. But I think the other two are related to this homeowner association effort, and that is the diversity of the field has been transformative, and we're still got a long way to go. But it's been really encouraging and exciting to see how it's evolved. And then our mandate for engagement and outreach. I know you guys can hear my dog. I don't know what to do about that. Can you close the door? So anyway, that's what I was going to talk about, those kind of three areas, because it's really changed a lot in how we do science. And so starting with technology, the biggest thing the most exciting development in the field of ocean science, and I think it applies to terrestrial-based sciences as well for me, is, aside from computers, which is super obvious, is GPS, Global Positioning System. Has made the work of observing and interpreting data from the ocean and atmosphere, or the ocean and land surfaces, tremendously easier. Even more so for the ocean than land, of course, because you have references points in the land that you don't have on the ocean in order to locate stuff. And that's huge, because it has enabled a lot of the things that I'm bringing to discuss later about are greatly aided by this GPS. In fact, it wouldn't be possible. And I included as a picture of the Everglades, that just was, you're able to, I'm able to go, and you tell me anywhere in the world that I might be interested in doing research, and I can go pull down the high resolution Google Earth image of this place in the world and look at how it's evolved over 20 years or so, depending on the amount of local satellite imagery, make measurements of things, do analysis and all that. And this is just completely changed the world of this type of understanding the environment we live in, from my perspective, in the last, when I started out, the amount of effort that would go into collecting an image like this of these tree islands in the Everglades and cost would have been, you might get one picture because you'd have to rent a plane, fly it, get the camera shot, maybe, and spend 6 weeks geolocating everything and making sure you had all your reference points right and everything like that. And and then it'd be a still image. It would be a print image and so you wouldn't have the ability to do any advanced analysis of that or import anything into a computer, and even more so as a ocean scientist. My thing was one of the things I did in graduate school was look at breaking waves on the ocean surface and trying to quantify their effect on things that you see in satellites. So literally, frame by frame, I spent time going through photographic images of the sea surface and trying to identify breaking waves in the images and counting them. And you could spend a day going through 30 seconds of imagery. So it's just a tremendous change in that sense, this ability to get this information. And now, but the other problem that we've always had as scientists that work in the environment and the ocean is that the number of people that use the techniques that we use is particularly limited, and even more so even in the ocean than in the terrestrial, because there may be hundreds of people around the world or dozens that might be interested in using a certain type of product, but that is specialized for ocean image sensing. But then you compare that now to cell phones and video games, and there's billions of potential people there. So the cost of the development and the technology is just skyrocketed the advancements. So as I said, the first thing I tell the students that come in to a lab with me is, which I'll start this spring, I'll start a physical oceanography lab, is use your cell phone. Use that phone to take the picture, to record the thing. You get amazed what you can get out of that. What you could, just taking that picture, taking that video, and that will enable you to understand things so much better. And it goes beyond just the cameras in the cell phones, the GPSs in the cell phones. The fact that everybody's walking around with this device that has got quite a bit of capability to make measurements, which explodes the use of citizen science. So that's really exciting. And the other thing is that for the game controllers and the cell phones too, that have the accelerometers, sensing the orientation of the phone and where it's moving is really important for physical sciences, or physical oceanography, a wave guy like me, and to have that capability. So it's really exciting for that. And so these things have been and right now I think we're at a cusp where we're really starting to take advantage of these things out there to get this much broader sensing of that. And I'll discuss about some of these autonomous platforms. And then at the end, and I'm far from an expert in artificial intelligence, but I work with people who are attempting to adapt this type of analysis or use of data to understand our natural world. And that's transformative as well. Okay, so here's an example of the use of GPSs to measure flows in the ocean. And this is some work that was done in response to the Deepwater Horizon oil spill. And this is deploying, and I'll have another slide with the drifters on it, what we put out here, but this spaghetti plot on the upper left side shows the tracks of 1,000 drifters, over 1,000 drifters we put out into the Gulf of Mexico and tracked them every 5 minutes as they drifted around the ocean. And this was the largest type of experiment of this type that's ever been conducted. 2030 was the most that ever been put out at once before this study. And this is one that I was directly involved in. And we learned incredible new things by densely sampling the ocean in that way. And if you look down at this, this is from the Gulf of Mexico, near where the Deepwater Horizon event happened. And this is where the outflow from the Mississippi River, if you look at slide A here, it comes out and meets the ocean water of the Gulf of Mexico. And that meeting point is a front in the ocean, like when you have a front in the weather pattern, when those come together, they create all sorts of turbulent motions on larger scales that cascade down to smaller scales, and like ocean storms, we like to call them, and a lot of these types of motions. And what this does is totally different than the way we used to think about ocean transport. And what I can show you here is that in this A through D is what happens to a group of drifters. These are these in the pink, and the original positions are in the pink and the red here. And you see that these are, the tails are where it's moving. But the thing that's of interest is, it used to be thought, like the Coast Guard would say, if you went down in the ships that sank, or the airplane sank or something like that, that over time, drifting objects on the ocean would just spread out because of dispersion. But what these drifters we put out here was showed that if you look at the scales on here, that over the course of about a week, all these drifters that were out over about 50 kilometers of the ocean got caught in these eddying motions and ended up getting folded on themselves, and all ended up within this 160-meter box. So all the pink ones here, and the black ones are different groups of drifters. And then after all that, a week, all these pink drifters were within 60 meters on the ocean. So this is the opposite of dispersion. This is everything collapsing together into a single point on the ocean. This is the kind of stuff that happens when you look at microplastics and things like that, these convergence areas, which are tremendously interesting and important. But it's really changed the way we think about it. It was this idea to, well, we're going to go, instead of just putting out occasional drifters, and say, we're going to really put out a lot and see what we can get with, because we were able to build these small, cheap drifters. That, which I think I have the slide later. I apologize to the organization. So then another example, this is the optics I mentioned, our ability to see things from using all this, the advances in optics, and this shows sea surface temperature. There's an infrared camera that you're all familiar with now with infrared, of course, because it's how they're taking the temperature of your forehead with for the COVID. We're taking an image from an airplane of the ocean surface at incredibly high resolution, so you're getting millions of individual observations of the temperature, and you see all this structure in the ocean. And then, another way that this is really of interest or advances the use of autonomous platforms. So the one that I showed you was a drifter, right? It just, this second, let me see if I have this is bigger. Since I'm talking about a lot, let me show this one. So this is what I was talking, this is the drifters we used to deploy in the ocean. And they said nobody had ever done anything to this scale. So we were like, well, we don't want to throw out a whole bunch of plastic into the ocean to do this. So this is a corn-based plastic that's biodegrades over time. Of course, we had a GPS unit in there, but that wouldn't biodegrade. Hopefully we'll get there at some point. I mean, the miniaturization will help with this as things get smaller and smaller. This was something that we had designed in the tank. There's a whole bunch of scientific questions about how you design something like this in a way that it accurately tracks what the water of the ocean's doing and not other things. And we this was how we use this, put all these out at one time out in the ocean. That was kind of the big development that we did to change the way that we sample in the ocean. Now, this is kind of a specialized thing, limited, a bit of a, like I say, a bit of a, we did something we don't like to do, which is put all that stuff in the water, but you hope that you can do this in a way that we can cover stuff. And that's where you have things that are actually autonomous and recoverable, they have motive control. Now, you're all familiar with drones, but we're now dealing where we have these three different fluids, the air, well, two fluids, the air and the water, and the interface between them. And we can have drones that propagate through each of those mediums. So this and these are, you know, this is just going to be tremendous for getting. One, they're relatively, well, the underwater drone in the lower left is not inexpensive. That's more than that's like a Porsche right there, but that's you know, that's an exception. The drones, of course, you can get a few $100s for something that can do the image. I took at the left, which is an image of bear cut from a drone that we use to understand the ocean currents. And then this one is also quite expensive too, but there's moves, you know, as you go to miniaturization and getting a lot of these things going smaller and smaller, the costs are coming down much more. For instance, we have a wave buoy that we're now using, or a motion sensor that's the size of a golf ball. You can put in the ocean and watch it float around and see what it does. When this was something that was normally the size of a you know, about a yard cube, you know, a sphere of about a yard to a much bigger size was what was you had to pack all the electronics required to do that in 20 years ago. So, but the drones, the use of drones and the combination with the imagery is allowing us to do really innovative things with tracking how the ocean moves and looking at that in a way that allows you to, and also getting some information on water quality, animals in the ocean and things like that relatively quickly over a small area. Now the problem with the UAVs here shown on the left, these little mini sub, this is about 6 feet long maybe, is that, okay, oops, is that they're slow. So you can cover, they also similarly can cover very large distances over the ocean, but they only go at a relatively slow speed. So like maybe, you know, half a meter a second, a couple feet a second, or a few miles an hour. And so as they move, the fluid, the water evolves and changes a lot as they move along. If you're trying to sample large ranges, you don't tend to get a very big sampling. You need a lot of these things. But this is really coming on, and I think this is really going to change the way that we sample this. And then this is one that I know is pushing a lot, which is a pretty innovative platform. It's called the Sail Drone, the one in the right-hand side of the image. And that's a solar-powered, wind-powered drone that's like a surfboard with this sail on it and all these sensors above and below. You see this up here. And basically you can just set that out there and you know, program it to do its whole bit without using any batteries or without using any gasoline or anything like that. And it's doing its sampling. And, you know, yeah, these are pretty expensive now, but if you can get those moving down in cost, then you can have a lot more of that type of routine sampling available. You can imagine going back and forth out from an area of interest, say Miami, and doing this. The problem we have, as I mentioned, the speed of these sail drones is somewhat limited too. And with the Gulf Stream, it makes using these types of underwater sensors in Miami a bit of a challenge because of the high speed of the Gulf Stream to keep things moving in that. But anyway, but that's a local, an us problem, not an everywhere problem. All right. Let me see what I have here. Okay, so that was about technology. Does anybody have any questions about any of those things that I was talking about there? Hey, Victor. I think you're still muted.
You're muted. I'll ask you to unmute.
Great. So I sent you a question in chat. So those floaters, are they satellite monitored? Are they, you have a ship that's out there?
No, that was the key thing. That was a lot, is that they were satellite communicated, but GPS monitored, but we had a GPS on board. So 10 years ago, before the standard system would talk to a system called Argos, which had about you could get a data point every hour or so, a couple hours, and you had about 100-meter resolution and send up this signal to Argos. And when we started this project with the money that BP put in for research after the Deepwater Horizon, we said that we wanted to put out hundreds of drifters at once. That was hundreds is the first time, thousands was the second go round. And the key thing was we had to get down to 5-meter scale resolution of each sample, because to understand these kind of really complex motions, 100 meters isn't enough, and every 2 hours you're really not sampling the kind of sampling that we want to do. So we, with the GPS on board, talking to the satellite system, we can get down to, like I say, 5-meter resolution with these, and sampling every 5 minutes. You can really see the whole way, kind of the way the whole ocean breathes and moves. It's really neat. And of course, this is the kind of technology like, going into driverless cars and all that kind of stuff, that kind of constant positioning and communicating and all that.
So it's real-time data transfer, not like it's saving it up and transmitting it to you once a day or once a week. You're getting it constantly.
Yeah. That's the way we were doing it. Yeah, sending it out. I mean, if it had a gap, it could hold that information for a little bit if it wasn't able to communicate. When we did this with these small drifters, there was a lot of concern that you would lose a lot of data because of the waves. Like they'd occlude either the communications or the GPS as it went. But we really didn't experience too much problem with that. So.
Okay, because as a homeowner and as a museum person, I'm always interested in things that people can look at in real time to kind of see science at work. I'm always amazed, when the what's the one, the great white shark that's tagged and people can watch on a web page the annual migration of these animals. It's always kind of an interesting thing to get people more interested in science.
Yeah, I mean, that we certainly were able to do that, during the time that they were all out there. Again, they're not staying out there because they're in the Gulf of Mexico and in the Florida Straits in this time, so they kind of moved through and out. But you could track them, of course, all the way to, some of them into the North Atlantic. We had a drifter like this in Greenland last summer, the fjords, and you can, I can sit at my desk and look at what the flow in the fjord is doing, in Greenland, which is pretty interesting too.
Thank you.
Okay, so diversity, in every way, shape, or form. Unfortunately, oceanography and engineering, the two fields that I work in, were slow to the game in diversifying, and we're in field oceanography, people that go out and make measurements were probably the slowest in the oceanography field, in terms of incorporating women and minorities into, having more involved in that. But things are changing. This is a picture. The woman on the right is Lisa Beal. She's an oceanographer in my department. She does a lot of work in the Argulis current, looking at global cycling of the Deepwater Meridional overturning circulation. And she goes to South Africa to work there and teach there. And this is something that's really being stressed, is the importance of bringing more women on, because really it's the first generation of female oceanographers are retiring now. Really, it's that short. I mean, I know, people that were the first to graduate from various schools and the first one to go on a NOAA type of cruise, and first of this, first that, and that generation is moving on, but it's just, we're still way behind, but it's getting better and better. And of course that helps all of us. And really changed. And then this is just a picture. I'm looking for something else here, but it's the use of integrative processing. This is a picture. And this is waves going over corals in the laboratory. And so we're in this project, I'm working with engineers, I'm working with biologists, we're working with architecture, we're working with artists. In the case of Xavier is doing some things related to that. And it's really encouraged by the federal research programs now to have these teams, and it's really exciting. I think many of us in the field are enjoying the opportunity now to work in collaborative teams where you're really trying to solve important problems. And that's a very big change, to solve problems and to also not just come up with a nice paper that you put out into a journal and then you pat yourself on the back and you go to a conference and you talk about it and everybody's, it's all the same community, but to actually get that out into the world and into talking to different people. And I think people like my age that have been in the field for a while, I know many of us find it to be very exciting times for that, because you get to, you're learning new things and you're expanding and building upon everybody's strengths to develop something that's even more than what individually you were. So this is an exciting time for that, and we hope to see a lot more of that going forward. And then the other aspect to that is, I don't really have it in the slide, is that back when I started in the field, there was very little data sharing that was done. So if I was involved in this experiment, like the drifter experiment, for example, and you collected that data, that data would be yours. You would defend it with your, with everything you had to make sure that was your data and nobody else got to use it. And you and your students were the ones that got it, and you wouldn't, it's always a battle to get somebody's data to do something. And now, not only are we mandated to share data by the agencies that do this, the National Science Foundation and others generally expect and require you to share your data broadly with everybody. Usually with some delay, so you have a little bit of opportunity to hold it in, so you have a chance to work on it a little bit before somebody else. But now you're really getting it out there, and a lot of it is to Victor's point, is going directly to the web with very little, and for everybody to access and use, and that's really a sea change, and a lot of it's driven by the amount of data available. Especially in the kind of work I do, where you're measuring things like physical parameters of the ocean and the earth. It's just nobody could ever hope in their whole life, to ever be able to do all the analysis that's out there available with with the information. So I know that most of us are happy to provide that information so that others can have a shot at using it and looking at it. And we like to use other people's data where it's available too. So it's really a change. And there's still dinosaurs in the field that, you can do some work with them, and you have to basically pry their data out of them like it's a dog with a bone in its mouth. But they're becoming more and more the exception. So that's something that I think is a really neat time now. And then the outreach and engagement. And this is just this team, and as an example of it was, this Bay Drift project, where we're looking at tracking these drifters that we used around Biscayne Bay and seeing where they go as they move around. And this was something that we're getting students involved with and trying to, and also doing the citizen science part of this was putting out these painted bamboo plates that they could, figure out where they are. And we mixed that with the plate tracks with drifter tracks, and I saw where things are moving around in the bay. So that's just an example, but it's really what we're mandated to do now. And I think most of us enjoy this type of activity. And the second part to this is getting involved and trying to get your science to make a difference in the community. And these are things that are unique or different than, or expanding. Maybe not, maybe it was always there to some extent, but it's certainly grown and stressed, and it's really looking forward, especially with this, with the continued the opportunities of not having the headwinds from the federal government, then this is looking really positive. So I didn't, I know there's a lot of stuff I probably didn't touch on, but anyway, those are some things that I thought were interesting directions for future science, and that was something y'all found interesting, and I'd be happy to answer any more questions that you might have if you have any.
Is this one, we looking at one drifter, 10 drifters, 25 drifters?
Now, this was a group of them. This was about, each of these lines, if you follow it, you see that there's red dots and stuff. So this is roughly about a dozen drifters.
Okay.
This type of work right now, they're both people at University of Miami and at FIU are being funded to develop computer models that can provide this type of information as well for the Bay. So, which Biscayne Bay is really lagged behind other similarly important or similarly known ecosystem, Chesapeake Bay or Tampa Bay, for instance. They have much more long-term advanced numerical modeling, computer modeling capabilities for understanding the transport. And Biscayne Bay, unfortunately, has not had that very well advanced. So the county, through the Corps of Engineers, is finally trying to upgrade their capability to do that in right now. There was an article about it in the Herald recently, and we've had discussions with those folks on how to use the data we can collect to help to get better predictions for their computer models. And this is important for, say, like there's a sewage spill in North Bay. Where does it go? How much does it mix in? It's important for discussions about how whether you should do the dredging in the boat basin, how much that'll change the circulation in the bay and affect the quality of the seagrass, the water in the North Bay for seagrasses or things like that. So there's a lot of important questions that we need this capability for that unfortunately the county has not had. And I think that'll be very exciting to have that come online. And hopefully it'll get to the point where that's going out on the web in a predictive, like in a handcast forecast way, where you can say, okay, this is what it was, and this is what it's going to be. And you could, look for the forecast for the currents in the bay type thing.
I have a question about citizen science and what you're seeing with different labs. Like now that the technology is available for more people to get involved, be it through social media or an app or something, are you seeing more labs try to incorporate citizen science activities or conversations into what they're already doing? Or what does that look like from your perspective?
I'd say the answer is yes. I think that it's something that I think many people would like to do, but it's not always easy to understand, to see where the opportunities are. Like it takes some creativity to think about how you actually can do this, but it certainly is happening. And another example in addition to this is, okay, so I can, for Biscayne Bay, this is I think there's a real opportunity for like water sampling stuff. Because the way the county does water sampling is they go out to these sites once a month and they take their sample of water, they send it to a lab, they analyze it. And they do that, they've done that for 20 years. Well, once a month just isn't enough to understand the variability in the system and also to alert you to problems before they become major problems. Like say oxygen levels are dropping in the central bay and there might be a fish die off or something like that. You'd be lucky if you're able to do it fast enough. So you can imagine things like that that could be done. I know that somebody that works in my lab that had previously worked in another lab, they were taking underwater photographs of plankton, and they were trying to identify them, the different species, but the only way they could do that, they were so irregular in the color and shape and all this stuff that they ended up posting them on the web, all these images, and having thousands and thousands and thousands of images, but basically it's going out in the world and saying, you know, here's the different types of things, can you catalog these? And they had quite a bit of success with that too. So there's some examples, and we're certainly encouraged to do that. You know, if I could write a proposal with a great citizen science component into it, then that's something that would help me to attract funding, particularly from, say, less task-oriented agencies like the National Science Foundation.
Thank you.
Is there potential for drifters to be used in the context of storm surge? Like, could drifters be used on water and on land?
Well, yeah, I think that, for instance, I don't have, I'd have to fiddle around. I probably have it on my computer, but I'd have to fiddle around to try to find it. But we had one of these, during this project, we had a bunch of drifters out in the water when Hurricane Isaac, which was a moderately strong hurricane, went through the Gulf, and they went right over them and pushed. You could see the push of these drifters as they went into the Louisiana Bight and Mississippi Sound. You can see how far up they were being pushed by this. So it's certainly an opportunity to, you know, you could try to get sensors in the water ahead of a storm to look at where they end up, you know, and you could learn a lot from that, how fast the water accelerated, where the pathways were, and things like that. And I know that the Navy is actually working on projects to do exactly that, to get sort of a, like, you know, the hurricane, the landfall chasers, like the National Weather Service and stuff, they have people, there's teams that go out and put weather towers on the shoreline. And so to try to supplement that with more coastal wave and surge measurements to understand better what's happening with storm surges.
Makes me think of that scene in Twisters, how they have those little orbs that they run after the tornado, and they get the tornado to pick up the
Right, yeah, exactly. And interesting, well, actually, one of the other things that okay, so, you know, when you get a GPS position, it's actually a three component position. You get a horizontal position, you also get a vertical position. So for decades, since they've been using the GPS on buoys, and so for a decade or so, they basically, the NOAA and the other organizations have not been looking at the vertical information from the buoys. And somebody that I work with at the university is got a plan to try to use all that archived vertical information to get a better, you know, distribution of measurements of the sea level from these drifters, because you have this fairly highly resolved vertical position on these things. Like if you looked at, you know, you can see how, you know, the regional sea level variability has occurred. So those are some other things you can do with these types of things.
Very cool.
Anybody have anything else that they think is particularly interesting in science or this type of thing going forward? We'll say one thing that I think that we're looking at, it's related to COVID in a way too, is the aerosol transport. And we've always been looking at it for things like salt transport and dust from Sahara and red tide and things like that. how those chemical compounds and biological compounds can get into aerosols and be transported off the sea surface, and for their human health risk, and whether or not algal blooms pose a risk. This is another combination of a problem with physical scientists and biologicals and chemists, really. So there's really a multidisciplinary problem that we're starting to address. I think that's pretty interesting. And it's this, the COVID problem essentially is, how are these little particles of these viruses that transported through the air, and how do the air currents change and all that. It's very interesting to those of us that do work in these in fluid dynamics types problems. I don't know anything about the virus, how it can do that, how it can infect, or what the characteristics are that allow it to be transmissible like that. But in terms of the physics of how it moves, those are the kind of questions that there's a lot of interest in, and there's oceanic analogs, like I mentioned, in terms of algal blooms and things. So that's something I didn't mention, but I kind of intended to.
It kind of sounds like there's potential to use nanotechnology. I mean, you have these.
Absolutely.
Yeah.
And nanotechnology is very much on the table. And I should have mentioned that, in fact. Thank you, Jamal. Because, like, one of the real problems, and I showed you a lot of nice physical data and waves and currents and things like that, and our ability to measure that remotely is pretty far advanced compared to, with the accelerometers and all these things and the images that I mentioned, compared to the biological and chemical sampling. But nanotechnology offers an opportunity to put these, for instance, to put these smaller nanosensors that could go, say, in these drifters that are going through Biscayne Bay, or in an ROV, you can put them out and either have, or if you put them in one side, just to continuously sample the water and send that information, so you don't have to go back. You have a continuous record of what's happening around the bay. You could feed into the model, really do that. Or you could have it go out and sample in areas of interest to see where the low oxygen is killing the fish and things like that. Or particular chemical compounds that might be there. And there's people that are at the University of Miami's med school that are working on nanotechnology to put on autonomous underwater vehicles and go out and make that kind of measurement, as well as working on the airborne toxins associated with, say, fires. This is a program that came out of burning, like the World Trade Center fires, with all the firefighters getting sick from the toxins in the air that they're breathing. And it's a problem for firefighters generally, because they're exposed to all these nasty things. And so they're trying to get these kind of sensors that you can wear that could automatically tell you when you're facing a hazardous environment, as opposed to have to wear something that takes a sample, you send it off, and a couple days later you find out that you were exposed. So those are things that are in development, I think, are very transformative, and as they come online. Yes, Victor.
You mentioned earlier about, really, I guess it would be crowdsourced ideas for data collection. We have cell phones, we have GPSs in our cell phones, and I'm recovering from COVID. I know they have my cell phone number. I wouldn't be surprised if they're tracking me to see some kind of long-term study about who interacts with who. Are there examples of people using crowdsourcing data collection and oceanography?
I know that, well, right now, Waterkeepers was trying to do something with, I think it was, you go out and you take a picture of a flood event with your cell phone, and you geolocate it, you send the imagery with some kind of reference. Say you took a picture of a street sign on the corner of if there's a bad flood, in Palmetto Bay somewhere, you take a picture, you send it in, and they have that, that local reference of what the flood level was, and that information is relatively hard to collect. So that's an example locally. I know that people are trying to get a handle on that. They're mostly using that in the context of sunny day flooding right now. And I'm sure Xavier has other examples because he deals in this realm quite a bit. Maybe he doesn't, maybe I put him on the spot, but but this is where creative ideas on how to engage the community, and it really, you know, it's again about having these kind of teams where you can bounce ideas from people with different disciplines off, people that might, you know, be in the classroom with, you know, people, you know, the community doing more of that or something. So I think that's one example, you know, if you can just have that. And then, like you say, the COVID example of tracking who you were actually exposed to, of course, that information is there if you need to use it. I know that our medical school people are trying to use that information. You feeling all right, Victor?
Better. Still can't smell, which is kind of convenient. But myself, my 3 daughters all got ill. My wife neither got ill, nor did she test positive for antibodies. So she's just Wonder Woman.
That's good.
But I thought it was interesting when I see these crowdsource studies of, say, spring break crowds or people on vacation. Or I would imagine somebody's doing it for people visiting Disney World and Universal and returning home from vacations and trying to relate that to infection rates or herd immunity rates. It'd be kind of interesting. And I was thinking, this is afield a bit, but I was out on a boat the other day, which had and I don't know what it's called exactly, but one of those systems where you can see the other boats and see the names of the boats, kind of like a transponder thing on an airplane, but it was kind of new for boating if you got those kind of advanced navigation systems. And you know, one of the things it does, it tells you whether or not you're on a collision course or when you're within certain ranges. And I thought that was pretty fascinating. And I was kind of wondering whether there's some kind of way to use some of that data in a scientific fashion, particularly if you've divorced yourself from the names of the vessels, just like in the cell phone example, we divorce ourselves from the names and personal data of the users.
Yeah, I know that that information is in fact being used. I know that for things like a lot of management aspects for, like, you know, enforcement of fishing zones and things like that. That's really an area with a lot of work, and I can't remember the acronym for it right now. I know exactly what you're talking about.
AIS something.
AIS, right? Okay. I'm at that age where things just don't come as quick as they should. AIS, yeah. So,
I blame it on the COVID.
I don't have that excuse.
Feel better there.
Yeah, I hope you.
Everyone in your family, except for your wife, has that. Hey guys, before we wrap up, I just wanted to see, and I don't want to put her on the spot, if our vice mayor wanted to just say hello to us. You sort of, I know it's late, it's, you know, we're already beyond our meeting time, but just share a few words and maybe tell us if there's something we can do as her neighbors and as a group to help push the agenda, her agenda at Palmetto Bay, or our agenda at Palmetto Bay.
Thank you, Xavier. I am very pleased to return to the group as the vice mayor. And honestly, I see an application of what we're talking about with one of the items that we just passed in the last council meeting on Monday night. And that is, I am fascinated with the application of the ability to track changes in the elevation of water, especially Biscayne Bay. We were talking about Salada Estate, and one of the justifications for a certain project. Sorry, one of my dogs decides she's part of the conversation. So,
Sure.
We justified part of the project that we're going to do at Salada with some shoreline stabilization, and the access to satellite images over time of our coastline, and perhaps even our canals in Palmetto Bay and throughout South Florida, can give us some data that help us justify or explain or even perhaps negate the need in certain areas or prioritize where we need to work for shoreline stabilization. And so I'm fascinated by what Brian and his colleagues do over at the Rosenstiel School.
Great.
Yeah, I think there's certainly a possibility. I know that there's a gentleman who's now, he had been at University of Miami, is now at Florida International, called Shimon Widowinski, who has made, that's basically been his career's work, is trying to understand water levels in the Everglades from satellite imagery and looking at changes and things like that. So that type of work is certainly something that could be followed up on.
It's gonna continue to increase in need as far as what we need to access and what we need to understand.
Yeah, having a good database system, or the good, which I'm sure you guys have, is key for that too. So you can
Thank
just
you, Xavier.
Pardon?
I said, and so thank you both of you. Being part of this group is very important to me, and I'm glad that I could make it back in any context.
Right. Well, I'm glad to see you. Thank you.
Let
Good
us
to see
know.
you, Leon.
Let us know, and we'll get the email for the FIU professor over to you. Or of course, just stay engaged with the meetings, and we'll see what we do.
I plan to keep learning.
Yeah, that's why I'm here. In fact, that's the whole purpose of this meeting, from us to learn and be curious and inspired to continue engaging. And just like Brian has a citizen scientist do his work for his big projects, in many ways, we're all citizen scientists here, right? We're learning and trying to figure out what to do. So yeah, having different perspectives makes something better and stronger, and that's what we're doing. And how awesome to now have policymakers sit among us, right? That's where the rubber hits the road. So thank you. Thanks for being part of our team. All right. Well, everyone, Brian, thanks so much, for the presentation. I miss being in the lab. I haven't left my house in 9 months. My God, I need to get back to that lab. But thanks. We'll put together the list of the speakers for February, March, April, and May. And I can't wait until we actually meet again at the Hibiscus Gallery, until we meet again in person. We're doing this now. And I know our numbers will swell, and there'll be all sorts of excitement and, dynamic efforts. But for right now, we're holding the fort. Even some of us who are still, not tasting are here. So thank you, Brian. And thanks everyone else for coming.
Right.
Victor, if you haven't seen it, you have several well wishes in the chat room.
Well, thank you. And I'll repeat, I hope that when we do be able to meet in person, that I've got a beautiful 1940s restored bar car at the Railroad Museum. That will be a great, fun place to sit down and get together and chat.
Hey, let me know
Thank
what the
you all.
elevation is over there so we can make a marker for you. I know it's high. It's like 14 feet or something.
At the museum? Sure, I'll do that.
All right, guys.
See
Have a
y'all.
great night. Thank you, Brian. Thanks, everyone.